Hello and welcome to this section, Ansible Playbooks Deep Dive, and the first video of this section, Ansible Playbook Modules. In this section, we're going to start by looking further into Ansible Playbook modules with hands-on examples. We'll then move on to dynamic inventories, how to use them and how to create them. Register for registering information that is received whilst executing tasks, and then making use of this with later consumption. We'll also look further into the use of when. Ansible has a multitude of different ways for using loops, and in this lecture we'll explore the many possibilities. We'll look into the performance aspects and how we can improve our playbook execution with different approaches such as asynchronous, serial, and parallel. Task delegation, allowing us to run our tasks using specific targets. Ansible Magic Variables, a special set of variables that can be beneficial. Blocks, which allow us to structure tasks in a block with optional recovery approaches. And the Ansible Vault, for securing information. Let's get started with Playbook modules. Ansible is a batteries included framework with thousands of built-in modules covering a multitude of areas and technical specialities. In this module, we're going to explore some of the modules that are available that you're most likely to use in your everyday playbook creation. The first module we're going to look at in revision 1 is set_fact. This module allows you to dynamically add or change facts during execution. Let's try this out. Okay, so we're in the Dive into Ansible, Ansible Playbooks Deep Dive, Playbook Modules, and Revision 1. And if we take a look at the playbook, you can see we have a task which is actually using the set_fact module. And we're setting the fact which is our_fact. And this has got the value of Ansible rocks. We're then using the debug module to show and verify that we have actually set a fact. Let's give this a try. And there we go. You can see that this is run against Ubuntu free and CentOS free, and we just have the custom fact shown there. If you now move to revision 2 and we take a look at this again, we can set multiple facts in one iteration of the facts module, as you can see here. We have our original our_fact, and we also have Ansible_distribution. In the case of Ansible_distribution, we're overwriting the default Ansible fact. As a reminder, the double curly brackets are used for Ginger 2 templating. The pipe designates that we pass into a filter, in this case the upper filter. Now, when we execute, we see that we'll have multiple facts and the distribution should be uppercase. Okay, perfect. Into revision 3. The setFact module is very useful in playbook creations when combined with the task directive of when. I've seen people use this quite a lot, where they set a common set of variables depending on the OS, then they use the common variables in their playbooks within tasks. If you recall in our exercise where we deployed our website using Ansible, we set the variants in Nginx locations using group vars. We could have used setFact for this, therefore removing the dependency on inventory variables. In this example, we show how we could set multiple values specific to the environment in question. Let's run this. And there you can see in the output we have the specifics that we would desire for the different platforms, i.e. Ubuntu and CentOS. And going back to the previous example where we had a different path depending on the distribution of Nginx. You can see we've got that there with var www HTML for Ubuntu and user share Nginx HTML for CentOS. The next module we'll look at is the pause module. As the name implies, it allows you to pause Playbook execution for a given period. It also allows you to do some other things such as pausing until a specific prompt is acknowledged. Let's go into revision 4 and try this out. When we run this, it will pause. We'll also get the option of ending this early if we desire with the use of Ctrl+C. Okay, so the first time I'm going to Ctrl+C this. And the next time we'll just let it run through. In this example, we've used seconds, but you can also use minutes. Moving into revision 5. The prompt functionality of this module is useful, especially if there are tasks that need to be manually verified before continuing, essentially prompting the user to take action. If we run this example, and you can see there that we got a prompt asking us to verify something before we continue. I'm going to press enter, and the playbook's finished. Into revision 6. If we look here, we have two different playbooks for this example. You may wish that rather than having to prompt and manually check that you could wait until a certain condition is available. The wait for module is great for this. If you completed some of the previous sections, you should already have a web server running, but just to be sure so we can go through this example, run the Setup Web Server Playbook. Okay, now that that's done, let's have a look at the wait for playbook. And you can see there that we're using the wait for module and we're waiting for port 80 to be in use. If we run this example, we can see that that completed as we know that the web server is running. Let's shut down the web server just on one of these. We could easily shut this down using SSH and service, but let's do this with Ansible instead. Okay, so this is stopped, so what we're going to do now is rerun the wait for playbook, but this time when we do it, we're going to run it as a background task using the ampersand operator. So you can see there we've got our prompt back, and this is running in the background. It succeeded for Ubuntu 3 as we know that that's already running. And what we're going to do, we're going to use Ansible again, but this time we're going to actually change the state from stopped to started. And that started, then you can see right after that our playbook is completed as the wait for condition has been met. In revision 7, we're going to take a look at the assemble module. We know that Ansible can be scaled to thousands of systems. When working on such a multitude, you may also have configuration files that become exceptionally large. Take, for example, configuration files where you have one entry for every server that you manage. You may prefer to separate your configuration into files for each particular system. This is where the Assemble module comes in handy. It allows a collection of files to be assembled into one file. We know that our CentOS 1 host is running on a different SSH port, so let's use this as an example. The SSH command line tool allows a configuration file to be specified for its config, so we'll use this accordingly. If we look in conf.d, we will have the standard entries that we would expect. In the defaults file, we also then have a host-specific configuration in a separate file for CentOS 1. This is our defaults, and this is our specific entry for CentOS 1. This is our Assemble Playbook, and here you can actually see that we're assembling everything in the source conf.d to a destination of sshd_config. If we run this, okay, that's run successfully, and if we look at our output file, you can see that this has actually assembled the two together. And if we try this out, it should work as expected. The beauty of this approach is that it's scalable and manageable. Imagine if there were thousands of hosts. Each one could respectively have their own configuration file that could be managed via source control, but when pushed through Ansible, they'll be assembled into one config for consumption. Next, we're going to take a look at the add_host module. This module allows us to dynamically add hosts to our playbooks for subsequent plays. Up until now, our playbooks have consisted of one play, but we're going to use this for multiple. Move into revision 8. In this example, you can see that we initially start with only our control host, Ubuntu-C. We're then dynamically creating two new groups called adhoc_group1 and adhoc_group2. And to this, we add in CentOS 1. Here we're highlighting that the add_host allows multiple groups to be used. We're then going to create a second play which implicitly targets one of the new groups and quite simply does a ping. Okay, so now we can see this executing against ad hoc group 1, which results in the successful ping of CentOS 1. If you quickly take a look at revision 9, it's worth pointing out when using multiple plays, you will commonly see the minus sign next to the host entry. Both approaches are valid YAML. As I included the informative comments, it makes sense to have this on a separate line. But the following is also perfectly valid, and it comes down to your preferences and standards. The next module we'll take a look at is group_by, similar to add_host. This allows us to add hosts to a group based on a key that is derived from facts. Let's take a closer look. We are utilizing the Ansible distribution fact, which would, by default, be Ubuntu or CentOS in our cases. We're using a Ginger2 filter to convert to lowercase, and then we're adding custom underscore to the name. The next play then implicitly targets all hosts in the custom underscore CentOS group. And now if we run this, You can actually see there that we've created specific groups from all of the targets that we had there, all of the CentOS and Ubuntu targets. We've created a custom_CentOS group, and then we've implicitly pinged all of the hosts in the custom_CentOS group. Finally, we'll look at the fetch module, which allows us to capture files from a remote host. Let's take a look at revision 11. In this example, for the CentOS hosts, we're capturing the file etc red hat-release, which will contain the release information for that OS version, and we're fetching these to /temp/red hat-release. And for each of these hosts that this actually runs against, it will create a subdirectory under /temp/red hat-release. Let's give this a try. That's it for this video. Join me in the next one where we'll be looking at dynamic inventories.